They will be doing January 2022, paper 2, number 5. Let's read the first part. The cumulative frequency diagram below shows the information about the distance d in kilometers that each of the 120 students walks to school on a particular day. So this is walks on a particular day. How many students at most walks 1 kilometer? So the distance is 1. So what you're going to do is, I don't have a ruler, so I'm going to use a line. 1 kilometer here. Right, that was 1. And you're going to meet the graph. And when you meet the graph, let's zoom. Oh my gosh. Right. Right. So we're seeing that it meets the graph line here. So what you're going to do is draw straight across and then read the value that you get. So it's going to be here. Now this one is a pretty easy one. If you look at this, this is between 10 and 40, there are 10 spaces, right? So if 10 spaces is equals to 10, then 1 space is equals to 10 divided by 10. So one of these spaces is 1. So this is 25, 26. Hold on, no, it's 20. Because the difference between 40 and 20 is 20. So it'll be 20 divided by 10 is 2. So this is 2, 22, 24, 26, 28, 30, 32, 34, 36. So we know that here is 36. So when they ask you the question of how many students at most walk 1 kilometer, your answer is going to be using the graph. It's 36 students. Right. Now you're going to look at this one. They ask you for the median. Now, median, lower quartile, and interquartile, there are certain things you need to remember. Your median is half of your total. And just a total, that is a half of 120, which is equals to 60. So what you're going to do, and this is 60%, right? So what you're going to do on your cumulative frequency, you're going to look for 60. Let's use, we'll use a different color. Right, you're looking for 60, 60s here. Right, you're going to go straight across with your line. Let's put it red. Right, and then you're going to draw a line going straight down. So we want, how much is this red line intersecting your x-axis, right? So again, you're going to use it if then therefore. We say if 10 spaces, 10 of these small little squares, right, is equal, what's the difference between 1 and 1.5? 0.5. So if 10 spaces is 0.5, then we want how many spaces? 1, 2, 3, 4, 5, 6, right? So then You always find for one space, so 1, which is 0.5 divided by 10, right? And therefore, we want 6 spaces. So that'll be 1 plus how much ever the 6 spaces is equals to. 0.5 divided by 10 multiplied by, instead of 6, you can also do this. Count from 0. This is 5, 10, 15, 20, 25, 26. So instead of 6, you could say 26 spaces, right? That's from 0 to the point. Multiply by 26 over 1. And when you do that, you're going to get 1.3. So we know here is 1.3 kilometers. All right, so when they ask you for using the cumulative frequency diagram, determine the estimate of the median. The median is 1.3 kilometers. The lower quartile, right, I believe is a quarter of the total. A quarter of the total, which is a quarter multiplied by 20 over 1, which is equals to 30. So we know our lower quartile is when my cumulative frequency is 30. So let's go up. 30 would be between here. So we'll use a different color to represent. This is lower quartile. Let's use green. And I'll zoom up. Alright, so we're going to make a next line, and this line is going to be coming down like this. Now, you need to pay attention because this line is actually coming down in between that space, right? So it will be 5, 10, 15, 16, 17.5. So we know, therefore, 17.5 spaces would be 0.5 divided by 10 multiplied by 7.5 over 1. Right? Which is equal to, 1 second, we need to just zoom in a little bit more for me to make sure that is 17.5. Right? No, it's actually right at the tip of 18. So it's not 17.5, it's actually 18 spaces that they want. Alright? So instead of 17.5, you're going to find for 18 spaces. So it'll be 0.5 over 10 multiplied by 18 over 1. And when you multiply that, why did I say 10? It's not 10. Yeah, no. Yeah. So this is 0.1. This is 2. So 18 space is actually 9 by 0.1, which is 0.9. So how much would be your lower quartile would be 0.9 kilometers. Let's read the third one, the interquartile range. Now, your interquartile range is a little bit special because interquartile range is equal to your upper quartile minus your lower quartile. And whatever answer you get there, no, it's your interquartile, not your semi-interquartile. So this would be it. Your upper quartile, oh, let's put the word quartile. Your upper quartile minus your lower quartile. Alright, we already know what is the lower quartile because we know that's 0.9, but we don't know what's upper quartile. So upper quartile is actually 3/4 of your total, which is 120. That's 90. Alright, and then you have to find out how many Alright, so your upper quartile is actually 90. So 90 would be between here, 80 and 90. So you're going to draw a line, and 90 is at, and find out how much is your upper quartile. Hold on. Right, 90 would be right here. Let's put that blue. So blue is your upper quartile, right? Then you're going to put the next line going straight down. It's actually after the first line there. So that would be 5, 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 30. 10, 20, 31 spaces. Thirty-one spaces would be 0.5 over 10 multiplied by 31 over 1. Alright, this is 0.1, this is 2. Right, when you put this in your calculator, 31 spaces is actually 1.55. Alright, so we know that your upper quartile, remember interquartile is quartile minus your lower quartile, so that's 1.55 minus your lower quartile, which is 90, which is equal, not 90, sorry, 0.9. 0.9, so interquartile is going to be 0.65 kilometers, right? And that is how you would find your interquartile. Right. Part C says a student is chosen at random. What is the probability that the student walked for more than 1.5? We know that probability is your desired over total. We know that your total is 120, but how much is desired? What do you want? The student that walked more than 1.5 kilometers at school. So 1.5, we're going to look. So they want more than 1.5. So it's from here, go straight back. So if we know that the total 1.5 is actually 80. We could, let me, not 80, 82. Right, I'll use a dotted line. So 1.5 is going straight up like this. Let's use purple. So if you look at this purple line is actually intersecting not at 80 but a little above 80. Right? We know each little space, one space was 2. So you go from here, go directly across. Right, that is 82. So your desired is 82 out of your total. So your desired is 82 out of 120, which is equals to 19. What am I saying? It is, sorry, no. Your desired is not 82. Your desired would be 120 minus 82 because 100, 82 is how much persons did less than 1.5 kilometers, right? So we know that would be equals to 38. So it's 38 over 120, which is equals to 19 over 60. So your answer for this would be 19 over 60. Again, your desired would be how much walked, not walked more than 1.5. We know that 82 walked 1.5. So anything above 82 would be walking more than 1.5. So it's 120 minus 1. 120 minus 82 would give you 38. 38 persons walked more than 1.5, right? And you just put it over the total, which is 120. And when you reduce this, you get 19 over 60. Right? Let's do the last question. Complete the table below and use the information to calculate the estimate. Okay, so first off, we need to find the midpoint between 1.5 and 2. So your midpoint, let's make this smaller. Your midpoint is equal to 2 plus 1.5. That is your highest value and your lowest value, all divided by 2, which is equals to 1.75. So this would be your midpoint, 1.75. Right? Then they want this here. Now, to find the number of students, which is F, right, there's a few things that you need to do before you start, right? You need to find the F, and then you need to find the upper class. Your upper class is your largest value in that boundary. So in this case, it's be 0.5, 1.0, 1.5, 2.0, 2.5, and it would be 3.0. Right? That's your upper class boundary. So your cumulative frequency is at 0.5, what is it? It is actually 12. Right? You could use the graph. At 1, it is actually 36. So if you look at this, you can use your ruler very easily. You're gonna at 36, which is this, so 36 is here, you're gonna go straight across and go down, right? And that's how we got our answer of, sorry, you're gonna, what nonsense am I saying? Right. So you're gonna check at 1, that is equals to 36. Then the next upper boundary was 1.5. At 1.5, you're gonna get your values. So what you're gonna do, right, is you're gonna get your upper boundaries, and then these upper boundaries would be a distance, and you're gonna use your graph to get your CF, your cumulative frequency. So at 0.5, your cumulative frequency was 12. At 1, your cumulative frequency was 36. At 1.5, if you check it, it was 82. At 2.0 was 112. At 2.5 was 108. And at 103.0, it was 120. That is how you get your cumulative frequency. Again, you're taking your upper class boundaries using a ruler. So at 1, you go straight up, and where it crosses the cumulative frequency curve, you go right across. That would give you how much 1 is equal to, right? 0.5 was 12, 1 was 36, 1.5 was 82, 2.0, so you go from 2, you go straight up to the graph. Yeah, 2.0 goes straight up to the graph, and it's going across here. That is actually equals to 112, right? And then you do the same thing for 2.5, right? So when we do that, that would give us our cumulative frequency. And our cumulative frequency helps us to do the rest of the number of students. So what we are going to do, your boundary here, this is 12, your cumulative frequency minus 0 is equals to 12. Then this would be 36 minus your previous cumulative frequency, which is 12, which is 24. Then this would be 82 minus 24, which is indeed 46. So then this value would be 112 minus your previous, which is 46, is equal to 30. So this region here is 30. Then this here would be 118 minus previous cumulative frequency, which is 112, is equal to 6. And then 120 minus 118 is actually equal to 2. So to get your number of students, you're simply taking away your cumulative frequency, the cumulative frequency minus the previous cumulative frequency. And that would give you these values. And then f of x is very explanatory. F of x is your midpoint, f is f, so you're simply multiplying. 1.75 multiplied by 30 is 52.5. And then 6 multiplied by 2.25 is equals to 13.5. Right? And that's how you would complete this table right here. So again, complete the table below using the information to calculate an estimate of the mean distance walked by the students. Now we're not finished, right? We did complete this table or the missing points. Now we need to find out your mean. Now your mean is equals to the summation of f of x over the summation of x. Right? What is f of x? All these values added up is equal to 100 is equal to 100 divided by, what is the summation of x, right? sorry, what am I saying? The summation of f of x would be all these. So let's just add it up very quickly. 3 plus 18 plus 57.5 plus 52.5 plus 13.5 plus 5.5 is actually not 150. I don't know where I got 150 from. It's actually equals to, sorry, not 100, is actually equal to 150. 150 over the summation of x. X is actually what? Your midpoint. So that is 0.25 plus 0.75 plus 1.25 plus 1.75 plus 2.25 plus 2.75. When you add all of this up, my mistake. The mean is the summation of f of x divided by summation of f. So everything in f of x, which is this, and everything in f is this, 12 plus 24 plus 46 plus 30 plus 6 plus 2 is actually 120. So your mean is going to be 150 divided by 120, which is 1.25 kilometers. And that is how you would find the mean. Mean is also x with the slash across, right? The mean of distance walked by the students on that trip. And that is the end of January 2022.